SwayamPrabha. Digital India. Educated India.
Welcome to the lecture of today. We have been discussing about mineral exploration and have started our discussion on the geological methods, although it is actually the geology which is at the core of it. We are looking for mineral deposits, and any piece of information that is to be generated by any other means is going to supplement this effort of actually discovering a mineral deposit. And so the over and above the geology is actually the most crucial part of it. In our discussion we talked about the different types of guides, like physiographic guides, structural guides, stratigraphic guides. Guides, as we have just discussed, there could be large scale faults or folded terrains. We have seen that in terrains where there is affected by folding, sometimes there are enrichment of mineral the ore bodies in the in different parts. Say for example, if we take a fold, as we have seen from one of our morphology examples of. So, we generally see that the areas in the hinge we get the mineralization either taking place in the fracture network, where the it is essentially the zone of the outer hinge part of the zone of extension, and several such layers which are folded give rise to deposits which we name them as the saddle reef type of deposit, and many such situations, many such deposit types which exist, which have been identified in different parts. So, folding in particular geological terrain will definitely act as an important structural guide. And also we have seen in situations like where originally syn sedimentary exhalative deposit is ZX deposit, as SMS deposit, or even sometimes a volcanogenic massive sulphide deposit, they during the process of their deformation they also get redistributed, and there are parts which are much richer part of the ore is localized, affected by the structure, and mostly the way sometimes there are some plastic flowage of the sulphide ore body from the limb towards the hinge zone, towards the zone where the strain is high. So, many such instances could be shown where many of the structural features act as guides or the indications where the exploration or the method of detecting the ore body or delineation of the ore body could be more focused. And then large scale lineaments coming out of shear zones, giving rise to lode type deposits which also extend for several hundreds of meters or sometimes kilometer scale, like the ones which we have shown in case of the Harbour Craton. And stratigraphic guides are also important, because we do have the example of ores being localized in unconformities. Of course, unconformities also is a structural, can be coming under a, but they do sometimes also are important stratigraphic markers, and they act as traps in which mineralizing fluid generally deposit their metal content and give rise to very rich mineral deposits, like the one we have seen in the unconformity controlled uranium mineralization in Athabasca basin and in other parts of the world. And then the lithology, which of course gives us the very fundamental idea. For example, if we are looking for nickel or platinum group of metal, chromium, then it goes, it is very as we have seen it very clearly that we have to go to areas where there are ultramafic complexes in the form of layered complexes or the bodies that we have seen. That is true for even if you are looking for titaniferous, vanadiferous magnetite deposit, we do have to look for intermediate rock composition of the anorthosite, which could be a part of this such kind of layered complexes or could be occurring as independent bodies like the Sudbury complex that we have seen, and many such rock. So, essentially what we essentially have put up or have proposed as ore rock or ore rock association. Before I put any more of example on this ore rock association, it would be rather relevant and important to just recall. So, what we are basically saying here, the geological model of origin of deposits at the back of our mind is actually is a fact that the mineral exploration program of today or mineral exploration, when we think of exploration, mineral exploration today, we generally are targeting any particular metal or any particular metal of a particular genetic type. For example, if we talk of situations like we are looking for copper, then we have to be very sure whether we are looking for the copper deposits, which we are essentially looking for a porphyry type deposit or a VMS type deposit or any other deposit, because we know that the geological setting, the entire the way the geological processes evolved in any particular segment of the earth's crust or the lithosphere, they are different. So, the exploration program or the criteria that is going to be used for this exploration program in different scales are going to be different for different type of genetic types. A program essentially targeting for copper in a VMS type deposit would be entirely different from a program which will be targeting for porphyry copper deposit, which will be discussing one or two case studies here. Because so here the concept is that if we can visualize any mineral deposit as a mineral system or a resulting from operation of geological processes in a particular sequence and the optimum scale of operation of the process in each sequence, which gives rise to a mineral deposit, a workable mineral deposit or the deposit which will be meeting our quality quantity criteria. So, that process has to be thought of in all its scales. For example, the moment we talk about the volcanogenic massive sulphide deposits, let us say of a Cyprus type volcanogenic massive sulphide deposit, what immediately comes to your mind is that we need to have a rift kind of a setting. So, if we are looking for a VMS deposit in any old terrain in anywhere in the earth's crust, then we have to look for, first we know that in terms of a large scale operating process, it has to be a either a oceanic or the oceanic setting, rift kind of a setting in ocean floor, maybe sometimes in a very close proximity somewhere there could be back or could be some kind of a convergent margin over somewhere there to give rise to a felsic rock which will be contributing the fluid and so on. So, whatever is the situation, whatever we have visualized, and we have come up with something which we call as a working model, as a working model on the genesis of any deposit type. All these we have seen, the whole spectrum of mineral deposits of all the metals that we have seen. So, this working model may be suffering from many shortcomings or many deficiencies or in terms of accuracy, or there are many opposing views to any proposed genetic model. But if that particular genetic model could be translated, so if this working model or the genetic model that we are talking about, if we can say that it's a mineral system So, this mineral system has some very critical processes. Then the example that we have seen, for example, is a volcanogenic massive sulphide deposit in which a rift has to be present. In any case, it has to be on a rift setting. So, identification of the presence of a paleo rift type of condition anywhere in the continental crust, it is the first criteria that has to be satisfied if we are making a program of exploration of a VMS deposit in that part. Then there will be certain, so that will be the process which is the highest or the largest scale that is operating, and when we go down in the hierarchy, we will see something that is some kind of constituent process coming to a region scale or to a regional scale. Then we see what are the processes that are identifiable there as a constituent process in terms of the rock type that is occurring there, and the kind of a fracture pattern that we have seen in the ocean floor rift systems and so on. And then again we can go to the next lower, the local scale processes constituents. For example, in case of a VMS deposit, it is a stockwork feeder pipe which shows its the typical type of alteration, then that which will be in the scales of only say hundreds of meters or even less than a square kilometer kind of area. So, there the constituent process is very much governed by the local scale processes. So, we have to see that each process has to be translated into its target identification kind of elements, starting from the largest possible scale to the deposit scale. For example, the alteration characteristics in that particular deposit would. So, if we get that those kind of very typical alteration that is observed in VMS type of deposit, then we become more sure about existence of such a deposit. Then we go ahead with our target delineation procedures using many different techniques, and finally end up with drilling kind of exercise to prove the existence of the ore body. So, it actually it is very essential that what exactly. So, the mineral exploration today is oriented in that way. It is targeted towards discovery of a certain genetic type of deposit of a certain metal or a group of metals. For example, we can have an elaborate program for exploration of kimberlite pipes in any of the cratonic blocks of the country. We can have an elaborate exploration programs for unconformity type uranium deposits in selected areas where where the geology is favorable, and so on. Say for example, if you are looking for porphyry type copper deposit, which we know are very rich sources of copper, then we have to look for areas where we should be getting a paleo subduction kind of setting or kind of suture kind of setting, where and then we should get the desired calc-alkaline magmatism in the form of what we have seen in porphyry copper deposits, and then come to the deposit scale processes as to how many different phases of this felsic intrusives are there, whether the alteration zones are there or not, and so on. So, these framework they provide the basic framework on which the geological methods of prospecting is based, which operates from the all the stages, because even if a particular drill ore body is being intersected by a drill core, the samples when they are brought up, the samples are examined, and the mineralogy, and not only the mineralogy, the very minute features of the textural characteristics of the minerals in the ore, which would be very crucial for its commercial utilization, would also be studied. So, a geological study actually is very continuously done from the very reconnaissance stage to even the project evaluation until the stage that an ore body is actually made ready for its exploitation. Then we talk about the geochemical methods. So, geochemical methods essentially we use our fundamental concepts of the behavior of elements and the behavior of elements in primary and the secondary geochemical processes. So, when we talk about a process of a magmatic melt being generated, and there the elements are the incompatible elements getting more enriched in that particular melt, and that melt is getting crystallized to form a rock in which it is giving rise to a hydrothermal system, and this the elements are getting fractionated, and this is essentially the concept in which it is a case of primary geochemical process or primary dispersion. And then the if that primary process has been able to give rise to an ore body, the enrichment of any particular metal to a higher value, higher commercial value or economic value, and that particular ore body has come into existence, has existed in the crust, and is subjected to secondary processes of weathering, alteration, and interaction with its environment for rock, with formation of soils and so many things. So, there the behavior of that element in the secondary geochemical cycle giving rise to the secondary dispersion pattern is the one which we need to understand properly to formulate our geochemical methods, and what essentially we are looking for in the exploration program. We are looking for essentially the anomaly or the halo. We have already while discussing the attributes of mineral deposits, we define them as representing anomaly in the crust, where the concentration of any of the metal or more than one metal is above a certain value, and so our basic objective is to identify or to establish the presence by understanding such anomalies in a reverse way. The ore body is concealed in a great depth, and then we have to do some systematic study so as to establish or so as to identify what kind of an anomaly it is. So, the geochemical methods, based on what material we are using, it could be a lithogeochemical where we are using the rocks as our samples for analysis. It could be soil geochemical or pedogeochemical method or pedogeochemical survey, where we are using the soil as the material for our analysis. Hydrogeochemical, where using water from different types of water bodies. It could be a stagnant surface water, it could be groundwater, it could be river flowing water, and there we are analyzing the water for the concentration of different metals, so the metals of our interest. It could be biogeochemical, that the plants that grow on the soil wherever there is a mineral deposits, we can sample the plants, take different parts of the plant and analyze them, and can also find out whether they are representing any normal or elevated or a anomalous value. And atmogeochemical, these things have also come into practice of late, to sample the air in the region where there could be certain mineralization of metals like uranium, from which we can have emanation of some rare gases like xenon, which could be their concentration could be higher, and we could analyze them and could establish or could help in detecting the presence of such kind of mineralization. So, all these, as we can see here, all these basically are dependent on one thing which is very important. In a geochemical method of prospecting, we are concerned with two things. First is the sample, and the other aspect is the analysis. They can be treated in two independent ways. So, sample is essentially the thing that is the decision that we are making on what is essentially the representative sample from what we want to analyze, a rock or a soil or a plant. So, here an improper sample can always lead us to erroneous results, and we can see them in a little bit of a details when we discuss about the geochemical method. Analysis is also important in the sense it depends on the capability, analytical capability. If we think of what was available before 3-4 decades or 4-5 decades, then the instruments which were available for analysis, their concentration ranges were pretty high. They could possibly go up to only parts per million kind of range, but now with the revolutionary development in the field of analytical geochemistry, with many high precision equipment that are available to us, like a like an inductively coupled plasma mass spectrometer, and there is where we can, or many other kind of situations where we can go up to parts per billion or even sometimes parts per trillion kind of analysis on concentration, which can be measured in the analytical equipment which are presently available. So, this has been a great this has been of great help in a geochemical exploration program as a whole, and identification of geochemical anomalies, which was not possible in the distant past. And we are not going to discuss much about the analytical equipment or the principles on which this analytical equipment work, and because they are beyond the scope of this particular discussion. So, we will only be talking about in brief about the geochemical methods. So, one thing we can keep in our mind, that we are talking about the primary and the secondary geochemical dispersion pattern or the mobility of the metals in different environment. If we take say for example, now if this is a situation in which in a crustal rock there is a deposit is somewhere hidden, now depending on if whatever is the metal here. So, its surface expression or the we are essentially will be able to sample or look at the situation where it is on the surface. So, it depends on the medium in which this body is placed. If it is only through just crystalline rocks, hard rocks, where the rock has not been weathered to soil, then the rate at which the that particular metal would have migrated in a concentration gradient would be much slower compared to what would have happened. And then the concentration, so if we measure the concentration on any particular any traverse, trying to find out the concentration, and this is supposed to be the immediate vertical distance here, the concentration is supposed to be the maximum, and the concentration should die away when we move from perpendicular direction in either way. So, suppose if it is a rock, the kind of analysis or the concentration profile which you will get might look like a situation which is very small, or sometimes even imperceptible or inconspicuous, or even less than what I have shown here, compared to the situation where this ore body, on top of it is actually a zone of soil, where there are soil pore spaces, and the pore space is filled up with water, and the mobility of the particular metal, particular element within this soil column, or the part which we call as overburden the soil. So, then the concentration which is exactly above when it is a soil, it could possibly become a much more prominent. So, this situation correspond to where it is rock, the second situation may be soil, but both actually be representing the presence of that ore body of the same dimension, same quality and the same quantity, but the reflection on the surface could be different. And so, here if we just make a visualization of this diagram, that conditions remaining same, if this particular ore body happens to be a far more richer, suppose this is an ore body where copper concentration is say copper concentration in the first case, suppose they are covered by the same material, either rock or soil. In the first case, the copper concentration is say 1%. It might correspond to an anomaly which will be small, whereas in the other case, suppose the copper concentration is about say 2.5 or even more than that weight percent. So, we will have a higher anomaly. So, the situation that I am trying to depict here, that what essentially we look for in a geochemical survey, geochemical prospecting program, to systematically sample. So, sample is a very important aspect of the work, because a improper sample will be give erroneous result, and in terms of the secondary dispersion or the anomaly or the geochemical halo that we get for different types of deposits or different situations, it could be so very diverse, so very widely varying situations. So, that is why the interpretation of the anomaly becomes a very tricky and important exercise in the geochemical exploration program. And so that holds good. So, if we are going for a program where the situation is that the ore body is only concealed under rock, then in the lithogeochemical, so we are sampling the rock. If the ore body is covered by a layer of soil, that is a soil geochemical method, where we are sampling the soil, or the hydrogeochemical. So, we have to, so this needs very well thought out plan for the sampling, and it needs a lot of pre sampling study, which is essentially goes by the name of an orientation program. And this particular method we are actually adopting when we are in the third stage, where actually we are going to the process of delineation of target, means getting preliminary indication of presence of such kind of an ore body from our reconnaissance and detailed geological mapping. We are sure that there is a ore body is existing, and we are going for its delineation in space in the subsurface. So, we are using this technique. Geophysical method also will be employed in this particular stage. And so, if we want to just summarize for this particular week's course, that we started with the completed our discussion on the Indian deposits, and then have briefly got into the topic of mineral exploration, trying to understand actually what we are exploring, what is the classifying the resources in terms of their identified and unidentified resources constituting the resource base of any particular metallic or mineral resource, and then understanding the basic purpose and look at the various stages of their mineral exploration from reconnaissance stage onwards. And so, we will be continuing our discussion on this topic of mineral exploration with taking up some case studies. Thank you.